Hello and welcome to this week's What Were They Thinking? This week's news items start with the use of cobra venom to deal with various conditions, but particularly flesh-eating bacteria. The FDA approves Eli Lilly's Alzheimer's treatment. A brain circuit that is possibly a good explanation as to how and why placebos somewhat ease pain. How one protein will improve lifespan, or at least in mice, which should be taken with a great deal of salt. Several examples of the rank stupidity of humanity, and why it is we are doomed as a species. Running shoes that are proven controversial due to the way they are altering competitive sports. A Australian state withdraws hundreds of different energy drinks due to issues around the caffeine content. The downsides to consuming organic, and how they seem to have a particularly high amount of what would otherwise be considered toxins. Ironically enough, a dark oxygen discovered in the depths of the ocean, nuclear power plants, examples of the failures of modern higher education, particularly with regards to awarding degrees, and various examples thereof, and the discovery of sulphur on Mars. The timestamps for these and other news items can be found in the description box below. Let's start with cobra venom. And snake bites are never fun, and for some people, snakes are no fun. But as long as they don't bite you, they're generally pretty harmless. Unless they're a constrictor, in which case, well, you have other concerns if they're that close. But despite this, cobra venom in particular has found itself being a popular target for research, largely down to the fact that it is a very potent blood thinner. That is, it prevents the blood from clotting, and this also creates issues around the ability of blood to stay where it's meant to be. And this, when given at a high enough dose, will lead to death, which is obviously the intent with the cobra. In other instances, the cobra just wants to deter you from bothering it, which is a perfectly understandable position. In other instances, yes, dead. But if you don't die, you can experience other damaging symptoms from the venom. This brings us to a possible treatment. It's something called heparin. Now, heparin has been used as a blood-thinning drug for decades, if not nearly a century now. And what's interesting is it's also used to treat cobra venom. So, the question has been, based from this research, how does heparin provide some degree of greater protection based on just simply being able to counteract the venom? And interestingly, it works in a way that's sort of similar to a class of drugs called heparinoids. And by taking heparin, or more accurately in this instance being injected with it, you're able to counteract the snakebite venom, the cobra venom. Further to protecting somebody who has been bitten, it carries other benefits. The first and simplest benefit is the drug itself will not cause a immunological reaction, which is not the instance, or not true at least, of some people with anti-venom, because most anti-venoms are based on something like an antibody. The second reason is that unlike antibodies, which are often very expensive, often require very specialized storage and so on, this is cheap, easily storable, and reasonably readily available, which means you can not just repurpose it, but deploy it with relatively little concern. The only question would be just ensuring that the dose is correct, which is a much easier thing to do than it would be with an antivenom. We then have the reality of the COVID-19 vaccine, and a large study looking at 2020 to 2023. And guess what? There are no deaths related to the vaccine. Yes, there have been a number of adverse events, but this is true of any vaccine. Now, that's not anything particularly exciting, as it's well understood the kind of indicators that say you probably shouldn't have the vaccine. But overall, there haven't been any real deaths. Now, we say haven't been any because the report itself indicates that there were fewer than 5 in total. Now, let's be clear about this. That's fewer than 5 as a total, but only where the vaccine was a contributing or possibly contributing factor. That means that it's not even clear if the vaccine actually caused it. And 5 deaths out of however many tens, hundreds, thousands, tens of thousands, or even up to millions of doses. And this death rate, or possible death rate, is a fraction of a fraction of a fraction. Admittedly, it is entirely based in Guernsey, so it's an island population and therefore limited in its ability to extrapolate out, except that this is consistent with every other study, so kind of obvious what they were going to find. Shifting to other drug-related news, it's the approval of Eli Lilly's new Alzheimer's drug, called donanemab. This is arguably going to be a massive boon for those with Alzheimer's, and certainly for their family. However, this approval does follow years of setbacks and delays, mostly owing to the fact that the FDA wanted more evidence of not only its safety, but to a certain extent, more data around the clinical trials and the advances that they were making. Otherwise, it largely followed the standard pattern. While that may sound wonderful, there is a certain caveat that needs to be made, and that is this drug is targeted at those in the early stages of Alzheimer's, and it will only slow the decline of cognitive function. This means it's not a treatment, and it's not a solution. All it does is delay, which, depending on how old you are when symptoms set in, and to a certain extent how long it delays the symptoms getting worse for, is a certain benefit. If you're old enough, you may well outlive the issues around declining the cognitive function. If you're young enough, all this really does is extend the time frame you get to enjoy the knowledge that you will gradually suffer until you don't even know who you are and die. Joy may not be the right word for that. The drug works quite simply. It's a monoclonal antibody, so basically it's an antibody that's intended for a single target and just made en masse. A monoclonal just means that it's the same cell that's producing it. The antibody targets the amyloid plaques that build up in the case of Alzheimer's disease, and because they've been tagged by the antibodies, the immune cells have a better opportunity to identify them and begin dealing with them. This means that the immune system should be able to clear them out from the brain slightly more efficiently, and therefore it should, in theory, work better. The only caveat will be getting the antibodies into the brain. But the other issue with this, and that's what has caused the delays in the approval, is just how Eli Lilly has measured efficacy. And at the moment, it has been approved and should be available within weeks. So we might be able to at least see a larger scale demonstration, let's say. Of course, you would need to also pay $32,000 for a year's worth of treatment. So, only in America. Moving on to another sort of study in the same vein of investigation, but this time not yet approved. It's a treatment for hair loss, but unlike most of the current treatments that often rely on things like hormones and similar, and in some cases simply replacing hair entirely, this relies on a sugar-based gel, and the argument is that the sugar-based gel promotes hair growth. Specifically, they're looking at using Deoxy ribose. It's a version of ribose, which is one of the more common sugars that are out there, and it's obviously also the backbone of DNA, DNA being deoxyribose nucleic acid. The discovery was somewhat fortuitous while researchers in the UK and Pakistan were examining the use of a sugar application for wounds. They noticed that the fur around the wounds that they had created was growing back faster than in the untreated cohort, which is, the discovery has a similar sort of fortuitous background as with Viagra, where it was intended for blood pressure control and ended up being gave rise to something else entirely. But while there's no definitive answer about why this works the way it does, the study of the mice did identify that there were certain alterations, mostly owing to the increase in blood vessels and the number of skin cells in the area. They believe that this may improve blood supply to the hair bulb and therefore improve hair growth. We now move on to the idea that it could just be the placebo effect, but the placebo effect isn't really well understood. However, one study now may possibly be able to contribute significantly to our understanding of why placebos help with pain relief, if nothing else. It's looking at a brain circuit, that is part of the brain neurology, that is exactly what's being triggered when you take a placebo, and that specific circuit, if it could be used more effectively, could well solve some issues around, to be blunt about it, the extensive use of pain medication, and often very addictive pain medication, for those who have chronic issues. Although, at the same time, mice tend to have a relatively short lifespan even if they are addicted to drugs, so the study they were looking at may not be all that much help, mostly because, well, a mouse brain anatomy doesn't always translate to human brain anatomy. The researchers found that initially conditioning mice to operate on the premise that part of their habitat was comfortable, and then switching this comfortable area to be uncomfortable, made the mice assume and certainly behave as though it wasn't changed at all, and this would indicate there's a certain amount of conditioning involved in the placebo effect. When they went into the brain, quite literally, by getting a microscope that was fitted to their head, they monitored the parts of the brain that were active, and they found the rostral anterior cingulate cortex was the area that seemed to be most activated. This is involved in part of the pons. The pons in turn is part of the brainstem, or the ancient part of the human, and in fact any other species with an advanced brain, a brain. As the researchers note, that part of the brainstem is full of opioid receptors that are effectively able to control pain that the human experiences, or in this instance, the mouse experiences. In further brain-related news, we have what has been a interestingly hyped-up article. It's a published article talking about reversing autism symptoms amongst dizygotic twins, which sounds great. The idea of being able to reverse the autism symptoms and effectively cure, and that word should be used with a great deal of care, the symptoms of autism. There's, however, one major caveat to this study, which is why it shouldn't be, how do we word this, taken as a particularly solid study. The reason for this is very simple. It's a tiny, tiny study. In fact, it is 2 children. This means that it would be more appropriate to describe this as a case study, not as a research as such, and it's for a very good reason. You can't rely on 2 samples to be the entirety of everything that you're claiming. What it does indicate is that there may be a pathway to doing something here, but you can't really say based on a study of 2. A study of 2 is not much better than a study of 1, the only difference being you put in twice as much effort. You need larger scale results, and particularly if we're talking about something as serious as screwing with people's brains. The researchers claim that alongside the allostatic load difference, the applied behavior analysis, speech support, the twins were given a relatively strict diet. A glutamate was removed from the children's diet, along with gluten and casein. They also provided a diet low in sugar, with no artificial colors, dyes, or processed food. Basically, they're trying to go all natural, and more so when they started on an organic diet, which basically means these people have more time and money than they do sense. The most egregious part of this publication, which should have had the editors and the reviewers absolutely throwing a fit, is the involvement of a naturopath. More so when they call it a naturopathic doctor. Naturopaths are not doctors. Anyone who is a naturopath who calls themselves a doctor, without also having got themselves an MD qualification, is scamming people, and is acting illegally in many jurisdictions. As said already, naturopaths are scam artists, and nothing more, and more so when they're trying to provide genetic counseling and treatments based on DNA analysis, which they're not qualified to provide. When you add in everything else that the article describes as done as an intervention, there's a case to be made that rather than the twins being better, they just wanted all of the punishment in the form of invasive treatments, all these strangers, weird things going on in their life, to stop, so they stopped expressing themselves as much, and therefore they're considered less autistic, which, yeah, that's about as much use as beating the child into behaving themselves. Other than the stupidity of that article, we have a similar kind of disappointing result, and it's not necessarily that it's wrong or bad, only that it is limited in its value, and it's the role of one particular protein in extending rodent lifespan by up to 25%. And therein lies the key: rodent lifespan. The protein is called interleukin 11. It's one of the inflammatory processes and molecules responsible for, inflammation. And fundamentally, what it's intended to do is to tell the immune system there's something going on here. Start making tissues more permeable to cells, start increasing metabolism, so on and so forth. By shutting it down, or at least by reducing its prevalence, you could extend rodent lifespan by up to 25%. Now, this sounds all well and good, except in order to do that, you need to genetically modify the rodents, which is a problem. It's not to say that there isn't benefits in doing so. For instance, there was a decrease in cancerous growth, but there was also a decrease in things like chronic inflammation and poor metabolism, which sounds great, but again, you have to genetically modify them, so the ability to translate this to humans is very limited. The reason it's targeted is that it's well known that interleukin 11 builds up in the body as we get older, and that actually makes a lot of sense, simply because as you get older, there is a greater turnover in cells. Cells get older, they die, there's damage to tissues. All of these are things that will trigger interleukin 11, so it makes sense. But that also means that you have all these associated issues. The problem will be that if you have interleukin 11 knocked out of these mice, is it going to affect their ability to respond to some sort of infection or pathogen? So, for example, if they have a virus like the ever-prevalent pandemic, or if they consume bad food and end up with food poisoning and so on, all of these are things that could possibly become complications and prove that although yes, being healthy without interleukin 11 is possible, you're also more vulnerable to certain problems that come from just being alive and, completing the circle of life: eating, living, and pooping. This does bring us to how humanity itself will likely end up, destroying themselves regardless of what we do to stop it, whether it's by removing interleukin 11 or anything else. It's a series of articles that demonstrate how stupid humanity can be. First, we have the New York Times, the headline that providing a small amount of doxycycline will, in turn, prevent things like syphilis, gonorrhea, and chlamydia. Yes, that's true, but doxycycline's also an antibiotic. Taking a small amount every day will indeed prevent you from getting these STDs, or STIs, whichever the current term is, but it's also going to wipe out the microbial flora of your GI tract, because, again, antibiotic. Continuously taking a small amount will mean those bacteria, or anything else in your GI tract for that matter that manages to survive, will develop resistance to this antibiotic, and of course any pathogenic bacteria that you happen to get exposed to will also be selected for their resistance to it. So this is basically making medication-resistant bacteria by simply training them. That is how bad an idea this is, and of course New York Times, so nobody should be surprised that they came out with this ridiculous headline without realizing the implications. A much older headline talking about teens boiling used tampons to get high. How and why this is meant to work is a complete and utter mystery, but just no. A rather terrifying freshwater organism, and it's similar in some ways to a jellyfish called a Hydra. It's a freshwater jellyfish, mind you, and according to at least the headline, they can reassemble themselves, which is somewhat untrue. Rather than saying that they reassemble, the chopped up Hydra will instead regrow itself and turn into more new versions of itself, basically clones. The same way you can cut off a branch of a tree and propagate it, it will still be a clone of the original tree, it just happens to start growing. Then we have the people who don't understand the idea that no, you cannot regrow limbs, fingers, or anything else. Once you lose parts of your body, large parts to be clear, they are gone. It doesn't matter what anecdotes you provide of individuals regrowing their severed parts of the body. That does not happen. Sure, there are children who will swear by it because they've seen someone take their nose or pull off their thumb, but no. The Metro's publication that the newest weapon from the army can fire lasers at the speed of light. Yes, lasers are light. That would be why they travel at the speed of light. Do they not understand that laser is in fact an acronym? The acronym LASER stands for Light Amplification by Stimulating Emissions of Radiation. It's in the name, light. Light is part of the name. It literally tells you what it is, so of course it travels at the speed of light. Slightly less stupid is the role of new shoe designs that are being described as supershoes and the effect they have on running. Most shoes that you would buy today, and particularly those for running, haven't changed much. In fact, the basic design has been fairly consistent throughout the last 150 or so years, but nonetheless, the modern technology aspect has allowed them to change very slowly. The development of Nike shoes in particular are what triggered the furor over them, and arguments that they provide an unfair competitive advantage. Examination of this, and certainly based on the published article in question, is that individually the parts of the shoe aren't any more advantageous, but the collective effect is, and with the current Paris Olympics about to start, and most recently the other various similar competitive events, it's raised claims that they are unfair and may yet get banned. May yet being a major caveat to that, as just about all of the either interventions or actions around this have limited their availability based on specific parts, and particularly around the general accessibility to the wider consumer base. In terms of wider consumer base, we have potatoes, and not just people being potatoes, but rather consumption of potatoes. It's a study arguing that consumption of particularly boiled potatoes is beneficial to your health, or at least, if you're a Norwegian, beneficial to your health. The study is interesting, mostly because it finds that if you don't fry potatoes and you treat them as a starch instead of a vegetable, it lowers your risk of all-cause mortality. Basically, if you're going to die of anything, well, assuming that it's not a truck-kun trying to isekai you, in which case you can do nothing. A truck-kun is the apex predator of the world. But it also reduces things like heart disease, so blocked arteries, hypertension, etc. The research found that people who consume more than 14 potatoes a week, so basically more than 2 boiled potatoes a day, 12% reduction in risk of death, and there is a rough dose relationship of 100 grams associated with a 4% reduction in death from all causes, which is interesting. Now, the study itself is useful only because of its sheer size. To be clear about it, not only do we have a breakdown by age, but we also have a breakdown by just sheer consumption. So we have diseases, age, size of the study, and everything else is really helpful. What they found was that, on average, you have a fairly large cohort who consume between 7 and 13 potatoes a week, and those who consume more than 14 potatoes a week. There's very few Norwegians who consume fewer than 6 potatoes a week, or at least by comparison to everything else. Of course, we do need to mention the fairly obvious problem, and it's quite simple. This is an observational study, and therefore you can find correlation, but you may not find causation. It's the standard issue to do with these sorts of studies. However, we do have a real example of things being withdrawn because there's a known correlation and causation. In Australia, hundreds of different kinds of energy drink have been withdrawn. So think of things like Red Bull, for instance. It's because they contain more than the allowed or permitted maximum amount of caffeine, and for the most part, caffeine is the active ingredient in just about all of these, whether it's a G Fuel, Red Bull, or anything else. All of them have caffeine as their primary active ingredient, no matter what the rest of the nonsense labeling says. Things like taurine don't really provide much in the way of benefit, nor for that matter any of the other real ingredients. The exception to that being sugar, and sugar is necessary for two reasons. One is because energy, but the other is that it counters the rather unpleasant taste of the carbonation, the rather bitter and acidified taste of the carbonation. At least in this Australian state, some of them contained more than twice the permitted level of caffeine, and typically the allowed amount is somewhere between 60 milligrams and 120 milligrams. That means that each of these individual cans contain the equivalent of somewhere between up to 3 and 6 times the equivalent of a standard cup of coffee. Shifting to environmental and agricultural news, we have an interesting development in Italy, and it's the juncture between sustainability, environmentalism, agriculture, and sustainable energy. It has Italy banning ground-mounted solar panels on agricultural land, which does make a certain amount of sense. If you want to grow food, you want food. Food is something that you really can't grow anywhere other than agricultural land, for the most part. Solar panels are far more flexible in where you can position them, and this is why the Italian government has approved the ban on installing solar panels on what has been labelled a productive farmland. While this may seem a rather extreme response, there is a good rationale behind it. Again, food security trumps other sources of energy, when you can, instead of using solar panels in one location, either put them somewhere else, or rely on different sources of energy, particularly in Italy. In other agricultural news, we have an interesting study finding that, if you're consuming organic, you're going to have more toxins in your blood, which isn't really a good indicator for those who claim organic is better and safer for you, more so when they say that it has fewer toxins. Clearly not the case. What they've done is quite simple. They had a simple test, that is, do we have in the blood of those who consume organic or in the blood of those who consume conventional crops a difference in concentration of various things. For example, lead, arsenic, various organochlorine compounds, and more. The way the organic industry sells itself, the answer should be obvious. That is, because organic uses fewer things like, say, glyphosate, or other things again, the answer is, it must be lower in possible pollutants. But no. It was actually very much the contrary. Concentrations of things like lead, arsenic, and organochlorine compounds was higher. That sounds rather damning, but there is a certain amount of leeway that needs to be given. The first is simply that it was a fairly small-scale study of Flemish adolescents, and the data did rely rather heavily on self-reporting of organic food consumption. They more or less tried to focus on those who consumed it more than 7.5 times a week on average. Now, the figures could be kind of terrifying when they're up to 40% higher than normal, which is a worry, and it's why the researchers certainly came back to have a look at what was going on. The effort to correct the record, as they put it in this article, found that it didn't actually help all that much. Simply put, the more organic food people consume, the more they're going to have toxins in their blood. However, what they did find that's at least somewhat more useful is that the consumption of things like eggs, dairy, seeds, and nuts contributed more to this than potatoes, vegetables, or fruit, which is at least somewhat more helpful. The researchers did try and spread a great deal of copium over their results, and this was done by claiming that the findings are not related to organic farming, but instead environmental pollution that contaminates the organic farms, which is just plain bullshit. That's certainly not an argument that's going to fly for conventional farming, and organic is not going to get away with it either. Further to that, the researcher asks whether or not there's a certain amount of fraud going on, which, yes, that's the entire premise of organic farming, a fraud. The claim that there are no chemicals used is bullshit, because at a minimum, they use water, which is a chemical. But then again, there are all sorts of other issues with the organic farming industry that we won't go into in this video. In a related news item, we have the most common herbicide used in conventional farming, Roundup, or more accurately, Glyphosate, as Roundup is simply one example of the product and one that's been largely discontinued for your average consumer. The news relates to Australia again, but particularly how a major class action lawsuit has, for all intents and purposes, been thrown out. Let's be clear about this. The lawsuit was trying to argue that glyphosate causes cancer. It's the same argument that was being made in America, but the American case was largely successful, sort of, in that it convinced the court to award the individuals money. In Australia, the difference is very simple and stark. The science won out. The science is fairly comprehensive and clear. To be clear about this, no pun intended, there are large-scale, long-term studies. These cover continents like Europe, and to a certain extent North America, where they follow hundreds of thousands of individuals who work on farms to see if the use of glyphosate is associated with any kind of cancer, and for that matter, other health conditions. And what they find when they follow all of these farmers is that no, there's not. When you have smaller scale studies, which are less able to detect variability and more prone to errors in what they find, those are what tend to pick up issues. And that's the issue. The sensitivity increases overall with the size of the study. This means if you have a much larger, and in many cases much longer term study, finding nothing, you should rely on that, unless there is a major flaw with it. And that's the thing here. Most of these small studies haven't been able to overcome that hurdle. The large studies have. The other thing is, this case, let's say, was a civil case, which means there's a far lower threshold to success. Rather than being without a doubt, this only requires a greater probability of causality, and they couldn't pass that threshold. This is both good and bad. Good in that Australian farms will be allowed to continue using one of the safest and most effective herbicides. The downside is that it could well continue to drag out the legal battle as the various lawyers involved appeal the decision. But it also means that Australian court, let's say, is not necessarily following IARC. That is the UN body that claimed that it's a probable carcinogen. The same group that wasn't supposed to publish that result until they could find if there was an actual risk of cancer from glyphosate, which the other body, the name escapes our mind for now, but found that there isn't an actual risk of developing cancer, so being a probable carcinogen doesn't really matter, and it's why IARC was told to wait to publish that result. Simply put, it was sending mixed messages, and one that Australia appears to have at least somewhat fallen on the right side of as far as science is concerned. In other food-related news, we have a study claiming that consuming fibre could have similar effects to ozermpic, but the important thing to note here is that it's, well, very preliminary and kind of questionable. The fibre comes from things like oats and barley and is called beta-glucan. Now they're arguing that it will alter the amount of blood sugar in your body and, at least in mice, lead to a loss in body weight. But those same mice were fed a high-fat diet, not a high-sugar diet, which is an important caveat to make to that. High sugar will lead to development of body fat. Consuming high fat will lead to high cholesterol in your body. It's a significant difference. The researchers argued that consuming a diet rich in this for 18 weeks drastically lowered the body weight of the mice involved in their experiment. The underlying rationale by the researchers is actually fairly straightforward, and it does make a fair amount of sense. That is, the different kinds of dietary fibre do provide the nutrition to the microbes within our GI tract. Simply put, what's not digestible to humans and becomes dietary fibre is digestible by microbes, and therefore, assuming you have the right kind of fibre available for them, they can use this. What they found was that water-soluble fibres, so for example, non-cellulose, so things that are fairly typically available in things like oats and wheat, are useful, so beta-glucan is an example, but so is dextrin, whereas you have others like cellulose and starch that aren't so available, and that's because the non-water soluble options stick together. This is good if you want nice solid stool, but not so much if you want your bacteria to be able to metabolize them. The researchers appear to put forward the idea that part of the effect of the differences in dietary fibre is the production of butyrate. Butyrate is a chemical that induces the release of glucagon-like peptide 1, which is what things like ozermpic are trying to do, and because of this, you're effectively achieving the same outcome, but rather than relying on external drugs, you're simply modifying your diet, which is at least somewhat more feasible, and certainly much cheaper than getting drugs in America. Well, prescribed drugs. The street drugs are much cheaper in America than other places. And going to a dark place now, we actually have a dark oxygen discovered at the bottom of the ocean. And this might sound weird and more like a Hollywood film, but no, it's an interesting oxygen molecule. It's the standard version of O2, that is, two oxygens bound together. But under normal circumstances, normally molecular oxygen doesn't really exist. That's because it's very reactive and tends to break up and become individual oxygens bound to something else. That's where this gets weird. The chemical reaction's actually working the other way around. Rather than breaking up O2, it's turning oxygen that's individually available into O2. And that's weird. As mentioned, it's not the typical way in which the chemical reaction should occur. And this doesn't require any life. This is purely a chemical reaction. So the question is simply why? And the researchers were confused by what was going on, and so they've tried to figure this out using several methods to measure oxygen levels. But over 10 years, and despite multiple methods, they found oxygen levels kept going up, which runs completely contradictory to what should happen. Oxygen levels in the deep ocean should continuously go down, except in these areas where they're covered by vast amounts of these small black rocks, and they cover wide areas. What are these small black rocks? Well, they're not Dragon Balls in the making, nor are they diamonds in the making. Instead, they're deposits of rare earth metals. And these rare earth metals include things like cobalt, manganese, nickel, and all the more else, all mixed up together to form the rock. And what's special about them is the same reason that we use them in batteries. They help to release electricity. They create a very low voltage, about 0.95 volts when they come together. And if you get enough of them together, they can create up to 1.5 volts. This is enough to remove the oxygen from a water molecule. And so, by breaking down the water, you can end up with not only hydrogen, but also the oxygen separated. And when they're separated, they come together for stability. They're kind of like sad people. They tend to come together, and then become even more sad. This does also present questions around not just deep-sea mining, but also already processed deep-sea mining locations that have not recovered, despite having been abandoned for decades on end. It also adds a possible explanation as to how life came to be. And next we have environmental activists being sentenced, and, well, unfortunately for them, they got 21 years after effectively desecrating the Van Gogh painting with soup. Yeah, these idiots desecrated one of the nicer paintings that exists by throwing soup all over it, and they got what they deserved by being punished. In less environmentally sustainable news, mostly because of the claim undermining it, China's nuclear reactor is claimed to be completely meltdown proof, which is nonsense. Not just because you should never trust a nuclear reactor never to be able to melt down, which is why it should always be monitored, but the method they're using for it is at least somewhat novel, let's say. The reactor relies on a passive cooling method, which is a great idea, as it does reduce the energy demands of the plant and certainly reduces what's required to run it. For example, you may not require massive cooling towers, but at the same time, if there are any defects in the design and you're relying on an entirely passive process, you have big worries. Because if something doesn't work with the passive process, you need to go to something active. And if you haven't set up the active process because you rely on this solely, you now have a reactor going into meltdown. we basically would get another Chernobyl. Except rather than getting a rather good TV series, we wind up getting, well, destruction and death. Another piece of nuclear news, although this time arguably somewhat more realistic. It's a startup that intends to create a very simple, very reliable, and very easily built series of reactors. These reactors are intended to basically be a copy and paste job that would be able to be deployed by 2030 or thereabouts. The idea is very simple. If you have a reliable design that works well and you can create multiple versions of it, it's much cheaper. And you can also roll it out anywhere, as rather than having to proof the concept, let's say, of each individual system and plant, you just have one and you say, we're putting it here, here, and here. And they'll look at the design of one and go, okay, that's fine. And then they can build the exact same design everywhere else. This would have a huge benefit in terms of cost, and that's one of the major issues with nuclear power plants. They require huge upfront investment because they are ridiculously expensive to build. The first plans alone plan to be able to provide up to 6 gigawatts of power. A gigawatt of power is typically considered enough to be able to supply a typical city, industrial city for that matter, of about 1 million individuals with all their energy needs. Of course, that assumes that there's no massive fluctuations, consistent demand, so on and so forth. And the next few items we have for you are all related to the same basic issues, and they're the award of various degrees, both at a master's level and at a PhD level, in things like psychology and similar related fields, for what is honestly truly terrible studies. And it's honestly amazing that anybody could possibly be awarded a higher degree based on what these people have done. And they're mind-boggling. The first comes from the University of San Francisco, and it's called The Impact of Compulsory Heterosexuality on the Sexual Identity Development of Plurosexual Cisgender Women. Okay, if we just disentangle that, it's basically trying to look at sexual identity and development. Which, okay, that could be useful, except it only involved interviewing 4 people. Yeah. 4 people is not enough, and especially when you seem to be guiding them in what you want. They were asked to reflect on how the messages they received in their youth assumed a impact on their not only femininity, but heterosexuality. Well, no. That's not how any of this works. Oh, that is a truly terrible study. And not just because of its small scale. 4 interviews is nowhere near enough to be able to do this, and especially not for a PhD. The next is arguably just as bad, although thankfully only slightly so. This is interesting in and of itself. It's from the Manhattanville University, and the thesis is titled An Interpretive Study of LGBTQ+ Community College Students' Sense of Belonging, an Assets Approach. Okay, this is only slightly better as it involved interviewing 12 individuals. But the difference between this and the other study is that this involved interviewing each of them for 1 hour, and their only interest was sense of belonging at the institutes they were enrolled in. No. Your typical interview is actually quite difficult to analyze. Not just because you need to conduct the interview, rather obviously, but then you need to transcribe it and then analyze it. The processes of interviewing often followed by at least 3 hours for every 1 hour of work in form of transcribing. And then you have to do your analysis, which can be several times again however long you need to analyze it for, and certainly in different ways. As a result, no. More so when the findings basically are, we want to figure out how to make it better for things like administrators, faculty, and staff to be able to support these individuals and contribute positively to the various alphabet soups. No. The next article is honestly even worse, and so we're going backwards in time rather than forwards, and it's from the University of Twente, and this one's titled Experiences of Non-Binary Youth on Romantic Relationships and Their Perceived Influence of Well-Being. This was only 5 individuals being interviewed. However, unlike the others where it was for a PhD, this is a master's level, which does mean the smaller number of individuals being interviewed is slightly better. Understand, 5 is still not enough to be able to really do much with this. In fact, very much not able to do much with it. Because you can only really say, these 5 individuals had this to say. And more so when the interviews were semi-structured, which is more or less a fancy way of saying, look, we need to keep them on focus and make sure they answer particular areas of interest. And then they use thematic analysis, which isn't so bad. Thematic analysis is fairly standard for this sort of qualitative bullshit. So arguably, we've gone from what is terrible to somewhat more terrible to slightly more terrible, but arguably it has its, let's say, merits, to the worst of all. And this is a truly heinous example of a degree being awarded, specifically a PhD being awarded to somebody who interviewed themselves. Yeah. The thesis is titled A Brief History of My Gendered Body and Autoethnographic Exploration of the Trans, Queer and Cuban Embodiment. Now, autoethnographs are basically diaries. Quite literally, it is fundamentally analyzing a diary of your own experiences and records. More than that, though, and this is where it gets truly ridiculous, and it's amazing that they were given a PhD for this, at least in theory, given it's being previewed, and the previewed is based on fundamentally the university having accepted it, that they say the primary psychology literature, or basically what is actually being published and peer-reviewed, does not reflect most of me and therefore has very little place here. It's another way of saying, I want to make up whatever I want, or the slightly more entertaining, it came to me in a dream kind of logic. The author also argues that because they're expected to justify their experiences, observations, and ideas by citing peer-reviewed literature, it's legitimizing the institutional violence. No. You're expected to achieve a minimum of academic ability and to achieve a minimum of academic capacity. And this has just been 4 examples of truly stupid failures at university level of graduate degrees being awarded. And we will have a video coming up on just how much of a failure academia can be when it comes to students, not just in relation to the failures in terms of this sort of bullshit, but more importantly, failures in terms of how they actually get students through their degree. Going on to the final news item we have for you this week, we're going all the way to the moon, and then further. We're going to Mars, and we're looking at what Curiosity has found. In fact, Curiosity has found a curiosity. It went through an area of otherwise unremarkable terrain. That is, until it went through a rather large rock, broke said rock with its very fat ass at about 900 kilograms or 1,900 pounds, broke said rock open and found yellow crystals. Now, yellow crystals may not be all that interesting to most people, except in this case, they're elemental sulphur. The sulphur is interesting as, well, it's fairly common on Mars, but it's not been found in pure form before now. Being mixed up in all kinds of other things hasn't been all that new, and it's quite sensibly so. Sulphur is somewhat reactive and can be all sorts of useful in chemical reactions and producing chemical products. But finding sulphur in a pure elemental form? Now that's interesting. Where this pure sulphur gets interesting, and why the discovery is very fortuitous, is that a pure sulphur in this elemental form will only occur under specific sets of conditions, or at least a narrow range of conditions, and previously none of these were thought to have occurred in particularly this region of Mars, and therefore, having found it, we can now say that, well, they must have occurred, because this wouldn't be otherwise. To an extent, this does continue to support the argument that Mars A could have been habitable for life, B has all the requisites for life, and C, we haven't yet found life, or at least nothing that we can substantiate. The things we have found include the necessary chemistry, the water that would be needed, habitable conditions, and, in this instance, one of the essential ingredients for creating amino acids, and also an important ingredient in proteins, particularly when we talk about structural elements. Now, that's all the news we have for you this week. Thank you for watching. If you found it interesting, consider liking, sharing, and subscribing. Please do post any comments, questions, or suggestions you have below.